when is this function now equal to 0? What makes this function? What are the roots of this function? When is this function 0? And this, what does that mean? It means what am I? What is my variable in this function? Yeah, what's the thing that I'm talking about finding the maximum power theorem, and that's basically says, what value of RL gives me maximum power. So what value of RL, and like I said, from calculus, we have the maximum power theorem, or actually it's called the maximum, I can't remember the name of it, but there's a name for that theorem that's basically how to find the maximum. And so if you take derivative of the function with respect to the thing you're trying to find is the, and get this, all right? So when is this equal to 0? Well, if RL squared is equal to R Thevenin squared, what is this? If these two things are the same, if these two resistances are the same, what would you get in here?
Isn't the max output your peak?
Well, no, I'm just saying in this function. Don't think about this. Go back to high school or middle school.
Is it 0?
If they're the same, what's this?
0.
0. So what's the answer?
0.
Well, no. What was the answer I was asking? When does this equal 0?
When they're the same.
When they're the same. All right. So, yeah. And we don't have negative resistors. So technically you could say when, plus or minus, so essentially RL is equal to, I guess actually when RL is equal to plus or minus R Thevenin. But we don't have negative resistances, so when RL is equal to R Thevenin. So I've just mathematically proven the maximum power theorem. Okay. So we get maximum power delivered to the to the RL when RL is the same as R Thevenin. And I found, basically, I was shaky on, I came up with two different answers, but basically, if I'd have gone ahead and done the algebra, I would have seen that they both came out with the same answer. So that's what this is saying. This is saying that this is the power law, right? Power is voltage times current. So what is that law?
Ohm's law.
Ohm's law. The VL is equal to I times RL. Or, what is this law?
Ohm's law.
Ohm's law again, just solving for I. And then, what is this law?
The voltage divider.
The voltage divider. All right. What is this law?
The amp divider rule. Current.
It's just basically you could say it's sort of the node voltage thing. It's Ohm's law, voltage over resistance. So it's Ohm's law. I actually could say it's Ohm's law. And I'm finding the current here, I. So if I use equation 1 and equation 2, you get I squared R. If I use equation 1 and equation 3, I get V squared over R. So but that's proving those where they come from. Then if I use 5 and 6 together, this is 5 and this is 6, I get this equation. So and then if I use 4 and 7, it ends up being the same equation. So this answer is the answer for the power of that Thevenin equivalent. And so that's what I'm using over here. So I just take that answer, come over here, and now I take the derivative of it with respect to RL. And like I said, that's using the maximum power, or not the maximum power, but the maximum value law, or whatever. Right, so this is calculus 1. Last class, I was talking about the fact that I already knew this law, and so this is the max power transfer law or theorem. And so I already knew this theorem, and so I was using that, and then I said, we could experimentally we can prove this because we can run an experiment, and we'll actually see that when RL is equal to R Thevenin, we'll get the maximum. And so I said, to plot that. So, all right, so I'm going to demonstrate the maximum power law graphically, and I'm going to come back to this equation 9 and 10, actually 8 and 10. 8 and 10 are identical equations, and so in Excel, I try to stay away from the corners or being pinned up against the wall. So I like to start down, somewhere away from the walls. And so I'm going to make use of using variables. So I'm going to look at my equation, 8 and 10, and I need a V Thevenin, I need an R Thevenin, and I need a RL. All right, that's the only variables in that equation. So I'm going to put V Thevenin here. So there's V Thevenin, there's R Thevenin, and then RL. And so I'm just gonna pick a value, So in your experiment, you have a V Thevenin you found. But let's say I'm just going to use, say, 5. And then I'm going to say R Thevenin is 4. And then I actually don't need this RL there. Well, yeah, I'm going to leave the RL there because we had an RL in our. And so let's say in our problem it was a 6. The circuit we've been using. So, or no, I guess it was R6 actually. So now I'm going to create a table because to plot you have to have a table. And I want to create a plot where this is power and this is our L. All right. So if you want to make this plot, how many columns do you need in your table?
3.
Why?
Because your starting point, ending point, and the one that's in the middle.
No, columns.
Column? Oh.
I need an X column and a Y column.
Oh.
Yeah, I'm on board.
So, I'm going to start my column there, and so that's going to be my. And what is my x-axis?
0.
RL. And what's a mathematical word? What's the mathematical word for the x-axis? or the RL. As far there's a certain name, they say it's the independent variable, and then the y-axis is the dependent variable. And because x is what you change, y is what the answer is. So RL goes here, and what's going to be in what's my y-axis variable? Right, the power, PL. All right, so I actually am going to use a third column because it's sort of, I found out doing this morning that because what I want to do is I just want to, I want to have an RL that's, I want my RL to start at 0. And then I want it, like on the, I was saying go from like 0.1, okay, of RL. So I want to start at 0, and then the next be like 0.1 RL, and then go all the way to like 10 RL. All right. And so, yeah, I think I'm not going to waste time doing it the wrong way. I'm just going to. So actually, I'm going to put my 0 there and a 0.1 there, and then Excel. I could just, I could have just said 0.1 RL or 0 RL, 0.1 RL, but if I
might have to join it back again.
If I put in the first two values, Excel will guess at a pattern. So, there's been many places in your education where you've had like, a sequence, and you guess what the next value is. So if I put my 0 and 1 at 0.1, and then select those two, and then grab that black box on the right bottom and drag down. Notice it's guessing that I want to increment by 0.1. And so I'm going to just drag that down all the way to 10. All right. So now I'm going to put in an equation. And in Excel, an equation has to start with an equal sign. Press equal, it automatically assumes you're going to type in an equation. So I want this column to be basically RL times this factor. So I'm going to put equals J4. The J4 is the address of that 0 row, and the first number is the column, the second number is the row. So I typed in J4, and you notice it highlighted and drew a little blue box around the 0. So I want to multiply the 0 times RL, and this is RL. So what's the address of RL? It's not this, it's this. So it's H6. Yeah, just look, it just happens to be the same as the 6 there. Now, if I just type in, well, I'll go ahead and do it. I'll just type in H6 times H6. So see how it made a red box around the 6. Okay? And now I press enter, and it calculated. And so if I copy that formula, that's what I get. Well, that's doing what it's supposed to do because Excel copies the formula, and when I type in H6, that's what's called relative addressing. And so it's assuming that I'm wanting to do the same thing here, but with this number. And so if I click here, see that it used H7. The third line it used H8. So what Excel's doing is it's guessing that I want to do that. Well, I don't want to do that. I always want to use 6. So the way to do that is, instead of H6, I do $H, $6. The $sign before the H and the 6 mean absolute addressing. And that means it's always going to use what's in H6. It's never going to mess with it and increment it and make guesses. So if I enter that, and now I copy that formula, it did what I want. And see, here, it's always using H6. You know, it never guessed and tried to implement that. All right, now, how many values do you think I have in this table? I mean, I'm going from 0 to 10 in steps of 0.1. So there's what, like 100 rows? Yeah. So here's where, you know, there's basically two ways to, you know, I can sit here and do this. You know, and then there's another way to do it that I'll show. Now, in Excel, if you want to go straight all the way to the top, real quick, you just press the Control key and the up arrow, and it jumps all the way to the top. So that's real useful because, especially when we're in lab and we take thousands of data points, you know, you don't want to sit there with your mouse trying to highlight a bunch of crap. So now that's all of my RLs. So the next thing is to enter the power equation. And so this is the power equation, equation 8 and equation 10. And I'm going to use V Thevenin, and it's always supposed to be 5. I'm going to use R Thevenin, which is always supposed to be 4. And then I'm going to use not RL, but this RL. So these two values need to be using absolute addressing. The RL will be using relative addressing. Because I want to always use the same V Thevenin, R Thevenin, and then use the changing RL. So I'm going to enter this equation. Now, it's real important to use a lot of parentheses, because if you don't use enough parentheses, Excel's going to make an interpretation that might not be correct. And the only way to really protect against that is use parentheses. So I start with an equal, and then I'm going to go ahead and start a parentheses, because I know that I'm going to input some stuff and then square it all. So that's what that first parentheses is for. And then I'm going to divide V Thevenin by a polynomial. So I'm going to be needing some more parentheses. So I'm going to put, so what should I put? How do I tell it the address of V Thevenin? I use a $sign because I'm going to use absolute. And then what's the address of V Thevenin?
H.
4. Yeah, $H, $4. So and like I said, for a long time, Excel didn't do this fancy color stuff, you know. But this is so useful because you instantly know if you made a mistake. You know, it clearly shows you what it thinks you told it. So that's correct.
What was that called? The one who used the $sign? Absolute what?
Absolute addressing.
Absolute addressing.
And then I need another parenthesis. And so, what's the address of R-Thevenin?
Dollar sign H, dollar sign 4, or 6, 5.
5. So $sign H, $sign 5, and it lights up the box, plus RL. Now RL, I don't want to use the 6, I want to use the 0, you know, that's in that first row. So what's its address?
K4.
Right, J4, and I don't use that dollar signs because I want it to update.
Do you use the J or the K?
Yeah, K. Yeah, K 4. And see, it did a purple box. Shows me I'm using the right thing. So I close that parenthesis, another close parenthesis, and so basically I've just entered this part. So the only thing left is to multiply by RL. I got to square it first.
Yeah, square.
So to square, you use the caret. Is that the caret symbol? I think the little house roof, and then 2. So that little roof means raise this to the power, and whatever you stick after that, which is 2. And I'm gonna put another parenthesis, and then times RL, and what is, I'm gonna use the same RL, which is K4. All right, now I know, you know, I'm missing a parenthesis. You notice how these other parentheses are bold? So that's, Excel's telling you that you've matched up those. See, this one is not bold, and it's a sign that, you know, you're not done. You got missing parentheses. You know, if I press enter, it's complaining. Now, hopefully, it doesn't delete my name equation. But all right, so I'm going to go back now and put in that missing parenthesis. Right, and then it bolded up the last. Now they're all bold, so that means I got them all in there. And now, we found a typo in your formula.
I guess they just got rid of your
Oh, I put the parentheses in the wrong
outside,
place.
Yeah.
So they corrected it. All right, that's good. So now I'm going to copy that formula. All right, so now I have all my table. And so now I'm going to, I need to select all that data. So here's a place where you use a shortcut. So I highlighted those two, and now I can do a Control Shift and a down, and it selects all the way down to the bottom. And then I'm going to do a Control. Oh, crud. I just can't do that. So now I'm going to say Insert. Here are the plots. I want a scatter plot, and I want it to be lines. I don't want any data points. This would be a big blur. Now this thing is way down here. I want it up at the top, so I'm going to cut it. So I just cut and paste. All right, so there's the plot. So you clearly see there's a maximum, and there's a minimum. And if we come back to this maximum value theorem, you can see that there's another, it looks like as RL keeps getting bigger and bigger and bigger, eventually that thing will eventually get down to 0. But, it's essentially going to be infinity. So there's another minimum at when RL is infinity. And so what is that value? You can use the pointer and sort of say, okay, 4.2, it's 1.56. Well, we know that the answer is supposed to be 4. So if I come back and look at my table, well, I don't have a 4. Yeah. So here's, but between, you notice at 3, well, at 3.6, it's 1.558, which is bigger than 1.53. All right, and then at 4.2, it's 1.56. So you can see that there's a maximum in there. We just don't quite have. Since it's only plotting the points that I told it to, or calculating the points I told it to. It's not. Didn't find that one. So there's a couple things I can do. One thing is I can use Excel to find. Well, I really need more points. But now this plot doesn't look like my prediction. All right. My prediction was like a bell, and if you take, if I plot this or make this x-axis logarithmic, I'll get the bell shape. Now logarithms, you can't take the logarithm at 0. It's undefined. And so I'm going to need to make a new plot where I start at 0.6. So I'm going to drop down one row so I bypass that 0 problem, and then I'm going to do another insert scatter plot. And then I'm going to come down and I'm going to format the axis. And I want to change it to logarithmic, and it's down here. See, now I get the bell. And so I'll do the same thing where I'll cut it and go back up to the top, and once again I see that maximum there. 4.2, but I said it would be 4 if I had chosen, thought ahead and basically chosen a value that, or I could go there and add the 4. Is another thing I could do. So I need it. It goes right in there, right? It goes after the 0.6. And so I can go in here and insert a row, and so now I'll just manually put in 4, and I'll copy this formula the same way, and so you can now see that that's bigger than the one above it and the one below it, and so see, it automatically updated my graph. So now when I come to the middle, I actually get the 4. So that is my maximum power. My maximum power occurs when RL is equal to 4, which is R Thevenin. If RL is less than R Thevenin, you're not getting maximum power. If RL is more than R Thevenin, you're not getting maximum power. It's has to be exactly the same. And so in my circuit, if my RL is actually 6, then this is what I'm getting. I'm getting 1.5 watts. You know, and if I tweaked it, if I changed my RL to 4, I'd get 1.56 watts. And you know, so that's 10%. Is it 10%? So if I calculate 1.56 minus 1.5 divided by 1.5. Yeah, then, you know, I can get 4% more power by changing my RL to R, making it equal to R Thevenin. You know, if I was like here, you know, the further you are away from R Thevenin, the more the difference is going to be. But, so that's what I want you to do, you know, in your report is go to Excel, use your values that you found for your circuit, your R Thevenin and your V Thevenin, you know, and your actual R6, okay, and then for these 3 values, and then calculate this, and then here, you know, basically calculate the difference you would get if you were to change your R6 to be the same as R Thevenin. And
So that RL will just be resistance number 6, right?
yeah,
Okay.
yeah, whatever you measured, what was ever in your circuit. And then when you save stuff, you know, like I said, like in, you know, what I like, you know, is the course, and then your name, and then the date. And
For the points, do you want us to go by 0.1, or could we just use like 1, 2, 3, 4?
nah, that'd be too. Well, the more points you have, the more precise your plot is, and yeah. Because you know, if theoretically, I would say because I knew what R Thevenin was, I knew what their answer was supposed to be. But remember, one of the uses for this is a black box, and so where we don't know what R Thevenin is. And I, you know, like I said, and one of the methods of determining the Thevenin equivalent is experimentally, not using any theory. And so, if I took a black box and I measured its V open circuit, and wrote that down, and I don't know if we even need that, but basically put a variable resistor out there and vary it and measure the voltage. When the voltage dropped in half, that whatever that resistor was is my R Thevenin. So if this data was coming from an experiment and you were only taking measurements every volt, you might have a big error in your R Thevenin. So and like I said, you know, and like I said, you know, in this case we know what the answer is, so you know you could at least make sure that you got the right answer. But
Can you tell us the matrix now?
yeah, the matrix.
The movie, not the
Yeah.
logo.
So
That just holds all the variables.
That one?
then
Yeah, look at that one.
yeah, know, this is the R, or I guess let's call it the G, and this is the X, and this is the Y, then Y is equal to, I mean not X is equal to G, inverse of G times Y. And so, so the first thing you have to do is find the inverse of the matrix. And so I'm going to enter. So the 1 and minus 2, and then 3, 8, and then 7, and 0. You go to where you want to put the answer. It's right there. And you say, go ahead and type in the formula.
So this is the actual.
And then you select. Close the parenthesis, press enter. Okay, then select that and
Oh, kind of like the way you do with the other one?
Yeah, create a
Like the
box.
formula?
yeah, but since it's two-dimensional, you can't just drag it, yeah. And so now you press F2, Control Shift, enter. And so there's the inverse.
Control shift with it?
Yeah, F2 and then Control Shift enter. All right, so now I need to use the matrix multiply. That's the M mult. And so I'll do it here. So I select the 7 and the 0. When I guess, yeah, I'm supposed to do this one first. Comma, array 2, which is the 7 and the 0. Close parenthesis, press F, press.
Then try that one now. Select that one, F2. Whoa. Okay,
Whoop.
there you go. Now select the box again.
The way you did the other one. There you go.
No. Select all 4 boxes. Or just 2.
All right, so I'm supposed to do, I'm supposed to select both of these.
Okay.
There you go.
There you go.
Now I'll do the F2, Control Shift, enter.
Yeah.
Nice.
So now, so that's the answer. Let's see if it's correct. So, so from this, we know that this is A plus 3B equals 7. And then this is minus 2A plus 8B equals 0. And so A is 4.
Plus 3. B
So
is 1
4 plus 3 times 1 is equal to 7.
Which is true.
Which is true. Right?
Yep.
True.
And then minus 2 times 4 plus
8 times 1
8 times 1.
equals 0.
Equals 0.
Equals 0.
So minus 8 plus 8 equals 0. Check. So you go to where you want to. So yeah, you type this in, then you go down to a place where you want to create your answer. for the inverse, and you type in the formula, and you're going to get, so yeah, so I'm going to just do another test over here. So I do equal the inverse, and then I highlight that. And then enter, and highlight that, press F2, Control Shift Enter. Right. So you create this, you create the formula in a blank cell, and then you press enter. When you've got it all done, it gives you one answer. Then you highlight, you start there and highlight the entire place you need to, because you know that the inverse is going to take up 4 cells. So yeah, that's where I put the formula. So I highlight these 4 places, press F2, and then Control Shift Enter, and then it calculates all the answers. And then for the matrix multiply, it's the same way. I enter my equation here, get the, press enter, then I highlight this place and this place, press F2, then Control Shift Enter, and it gives me the 2 answers. So, and then, so when I did this on the board, I just left all those R's as variables. So you could do the same thing here. You could, like I did in the previous example, type in variables R1, R2, R3, R4, R5, R6, and then V, whatever. And then that way you would have essentially a calculator that would calculate every possible answer for that circuit. You could put any different values of voltage and resistance. But see, if I come in here and change this 3 to 5, it automatically recalculates everything. That's one of the big values of Excel. It's considered a programming language. Because I've essentially created a program here that calculates. For any matrix, for any values I put in here, it would calculate the answer. Say I want to put this into a Word document, then so if I want to just get that plot, I click up here on the outside border, it selects that whole thing, and then I can do a copy, and I can go to Word. Now that's a picture, so there's a whole bunch of ways of pasting, and so if I just do a paste, this is actually an object that has all the data in it. You notice that as I rescale it here, what sort of messes it up really. It loses it's not the same, right? You can see that it's messing with the grid lines and all that stuff. All right. Well, if I do a paste special, there's a whole bunch of options. This last one, paste as a picture. See, it doesn't have all that other stuff over here. I don't know if you noticed on the other one, and all that stuff. And this one, this is just a picture now, like came out of a camera. And so I can resize this, and notice it doesn't screw up
Stays the
my
same.
grids. So this is the better way typically to paste as a picture. And if you look at the other options for pasting, that this says keep source formatting and embed workbook. So I've never tried that one, but what I'm thinking it's going to do is it's like this one, but maybe it's not going to mess up my yeah. So it's still now it's messing it up, but so I don't know if that is how much different. But the thing is, this has all the data. This has all the data. So if you send this file, your recipient gets the data too. Edit the data. There's the data. So. So let's say I wanted to get, like, I want to get that chart and the data. If I come up here and do that, and now do a copy. I did like a Control C, and then I come into Word.
Control V.
And yeah, you can do a Control V, but if you do the, well, I just did a right click. So it's got all. Look at all these. You got a whole bunch now.
Do the picture.
And so if I do the picture, so now it's like this is often what you want to do. You want to be able to show some of the data, maybe some calculations, and the plot. And then you can, if you double click on a picture, you can come up and crop it.